where everyone is, given the situation, and everyone's enjoying the evening wherever they are. I am now ready for the last episode for today of the building a 2-day game in Flutter. Obviously, there will be more episodes coming. So this coming week, I will stream at 7 p.m. here, which is 9 p.m. Eastern. Every day, you can find this on my Twitch channel outlined as well. The first thing I want to, so basically we had some good success where basically we were able to move the player, and every time we applied acceleration or thrust, it would actually show us an animation. For that, we created sprites and sprite sheets and all these things, and so that's all in the previous episodes. So if you're tuning in on YouTube or something and you feel like you missed that, make sure to watch the older episodes. What I want to do first is I wanted to kind of not have to import each asset one by one. So basically what we're doing right now, we're doing it like this. We are basically mentioning every asset by name. And then we're mentioning them again. Basically in our game props, we create these assets, image assets, and then we mention again the path to these assets. So there's no real point in doing that. And there's actually another way where you can just say, I want to include all the assets in a certain folder. So let's do that first. And we'll do that now because after we're done with it, we actually have to restart the game to make sure that the assets actually load correctly. So what we'll do is we'll just basically say we want to get all the images imported automatically. So, and so now nothing should have changed, but at least now if we add more images in the future, we don't have to mention them in two places. So let's see first if that works. And then actually now we're launching Chrome. I actually don't want to do that necessarily. I want to keep working on macOS desktop, so let's do that. So yeah, we will basically just make sure that works and then move on from there, right? So while we're waiting, we can actually look at some other. Okay, so you can see it wasn't able to load this. So this didn't work as we expected it. So what are we doing wrong? I mean, the only thing I could imagine is that this somehow, I mean, we have it exactly like, or maybe it has to be, it doesn't recurse maybe. So let's try that. Let's see if we actually, right, because there's a sprites folder in here. So maybe you need to at least go down to the folder granularity. The only other thing I could imagine that this only works so far with Flutter on mobile. Okay, but as we see now, it actually works here as well. So we just have to basically mention the folder. That's fine. So now we don't have to basically mention this all over the place all the time. So now what we can do, we can actually add in the walls. Basically right now, right, in our time app, as you can see here, we have some walls. We have some diamonds and health kits. We don't worry about those yet. But we want to basically, everywhere we have a wall, we at least want to show that. That also, and then if you have time, we will add collision detection. We have about an hour left today. So we'll see how far we get. So obviously, first of all, we need to add these images. And first what we'll do, we'll add the floor tiles. So the floor tiles are also a sprite sheet. And I'm again going to import it into our images folder. First of all, we're going to create a directory called BG for background. And so now we also have to make sure that we get that folder. Let's do it in alphabetical order. It's easier to see. And into that, we basically will put our floor. And it's an 8x8 floor. So we call it 8x8 to denote that this is 8 times 8 image, right? So we have the width 1024. So what we actually do, we'll take our game props, move them over here, and then we create that asset, watching the floor on the left to see we do everything right. So we create another, these are the floor tiles basically, and that is an image asset, and it is basically inside our background, and it's a floor. Actually, we don't need to call it the floor 8-byte because we see that. So let's just call it floor tiles, right? And it is kind of a sprite. We could just put it into sprites. It's going to be a sprite sheet, but just because we want to kind of separate out things that are actually active and moving and so on. So this one is definitely not moving. So and then we need the width and the height, and that's 1024, 1024. And then we need to know how many rows and how many columns. So 8 rows and 8 columns. Okay. So now we can basically create a sprite sheet for that. So that's what we'll do first. Let's see. And as you all know by now, I already did this before, and I can always kind of make sure that when I do things that, you know, I'm not wasting too much time, and I'm doing the right things. So let's see where we have those walls. Okay. Actually, hold on. These are not the walls. I'm wrong. This is actually just the background, right? So I'm actually going to look up. This was a long time ago, and I did this. So right. So first of all, so we will call this background. This is definitely a game part. It is not going to be anything that's active. It's not going to have a controller, because once we draw the background, we just have to make sure we render it, and that's it. There's not going to be a controller in there, but we'll still put it in our game, and so we call it background, right? And so in our class background, we first we need a sprite sheet. Our sprite sheet here, and so when we construct our background, we'll create that. So our sprite sheet will be sprite sheet from image asset, and then we just have to pull in the image asset, game props, assets, and then we have the floor tiles. Okay. So that's taken care of. Now we got our sprite sheet. And now basically we're just going to implement the render method. And actually let's make this a little smaller. We don't really need to see it that big. We render into canvas. Okay. So what we want to do, we want to basically render these rects. So like now what we'd have to do every time we get the canvas, we'd basically have to derive the rects, figure out where we want to render which tile and all these things, but that will never change, right? So what we actually want to do, we want to prepare this a little bit. So we want to init the tiles, so to speak. Right, and so so basically what we want to do, we basically have a sprite sheet, but also we will have a list of floor tiles. So let me try to understand. So basically, yeah. So basically, we need to take something in that tells us where we need tiles, right? because so this is going to be the thing is basically underneath everything, right? So, but if you have a wall, for instance, right, a wall covers the entire tile. There's no point like drawing a floor tile there. It probably won't hurt anything, but there's really no point drawing a floor tile everywhere. So also now if we do this right, actually, we already once we draw the floor tiles, we actually see the outline of our game, like of the walls and everything. So we need to take in the floor tiles as an input. And also we'll need the tile map in order to figure out where to draw, right? So we need a tile map. Okay. Let's see why it's not happy. Okay, here we go. So we also take that in. Okay. So now we can init the tiles. So first of all, we get the tile width. So just assign that to something to have a nicer way of doing things. And then the center, so that we can calculate the center from that, from the width. Right, but let's worry about that a little later. So what we now do is we go into the floor tiles will basically be given to us. So these are basically the positions where we need to draw floor tiles, right? And why do we need an index? We'll see that in a second. Length. What's wrong here? Oh, we need 0. Okay. Length. And then, so basically we're going to loop through all the floor tiles. And so why we need I is because we don't want to draw the same tile everywhere, right? We need to somehow figure out which one we will draw. And obviously we could use some randomization there, or we just say, well, we just kind of iterate through all of them, and then we'll start at the beginning, and then maybe the game would look somewhat repetitive, but maybe no one will notice, and we can always improve later. So what we want to do is the sheet row is I modulo 7. So that will be a number from 0 to 7, and since we have 8 by 8, right, we have 8 by 8, that will be perfect, and then the sheet column is the same thing. Except that it needs to be divided by n rows. We'll get to that in a second. Divided by 7. So this one, is some weird way of just distributing these a little bit nicely. So n rows, where do we get that number from? So basically the tile map will give us that. So you say final n rows equals tile map n rows. Okay, so that's where that comes from. Okay, so now basically we can figure out which tile we want to draw, and so now we say sprite, and now we're going to miss a method which we're going to run into the sprite sheet. We want to get sprite sheet get, right, we need get sprite. So we say get index, get row call, and we give it the sheet row and the sheet column, right? And so now we implement that method here. All right, and so basically it's very similar to index, except we need to figure out basically figure out what the index is. So we just calculate the index from that. The index is basically the sheet row, right? Which is basically the frames count, right? How many frames, right? So frames count is kind of a weird thing that comes from the animation. So actually I don't like that name. It's basically like cells count, right? Right, or it's actually the sprites count. That's pretty much what it is. We just should be clear about that. So it's a sprites count, and so basically we'll take well, in this case actually we don't need that at all. We just need the rows, the number of rows. So we take the sheet row, but instead we take the number of calls, right? And so here, so the number of calls, right? So that means like if we want to move to sheet row to the next row, we have 8 calls. We move there, and then we move there, and start counting here, right? So basically, you have to imagine that this is all kind of flattened out. We have been talking about this a while, so I'm not going to repeat this. But this is again mapping. Right now we're mapping like we're treating this as a matrix, but it's actually stored in a inside a one-dimensional array, and so we just have to do these little calculations to make that work. And actually, I don't want to call this sheet row. I'm just going to call it row and call, and then basically we return get index from index, right? All right. So now we got our sprite. Good. So we got that. Now what we still need to figure out, like where, basically where are we drawing? So we're going through all the rows, and we get the. So basically we go. Oh, let me think a little bit. So we're going through all the floor tiles. Sorry, we go through all the floor tiles. So now we need to get the tile. Floor tiles of I. Okay. There's a lot going on here, so that's why to make sure we don't lose track here. Now the world position, we need to figure out the world position. We got the tile, so that's the tile position. Then we need to figure out what the world position is, right? Tile dot to world position. Okay, so we got that. All right. Now we create a rect from that. It is basically rect dot from, so from left, so we use left right with height. So what we need to do is we need to basically figure out like the tile size. We need to go to the left. So basically what we're doing is, we make this a little bigger, or maybe do it here. So basically this is the actual position, but we need to draw the rectangle from here, right? So we just actually, since we are zero based also on y down here, so we actually draw it from here. So we need to go down and down half the tile width. So what we're going to do is we're going to say that the world position dot x. Well, actually, we need first the offset of that. Oh, we don't. No, we don't. Dot x minus the tile size by 2, like the width, and dot y by 2 as well, right? And then we'll give it the width, which is basically the tile size. That's why you assign it to this variable, because we use it everywhere, and it makes the code much easier to read. So now, so we got the rect. So we got the sprite. So now we know where to render it. And so basically what we want to do, we create a background sprite from it that we can easily render. And the background sprite, let me think about this real quick here. It will basically just store the sprite and the rect where we render it. And obviously we could actually add a render method to it as well. So we call it a background sprite, and it can be in the same file. It's so small, and it's very much related. So what we want to give there is we want to give it a we want to basically give it a rect where to render it to, and we want to give it a sprite which we want to render. And actually what we're going to do is we're going to say we're going to have a render method there. So now we just need to create the bar thing for that. A constructor is called. And then we basically will just create a background. Oh my god, I can't type. Is a background sprite, and we give it the tile. No, sorry, the rect and the sprite. Right, and then we just need to basically add that to our list of sprites. So we have a list of background sprites. Let's call them background sprites so we know we're not talking about normal sprites. And so those we initialize here. Okay, and then here we just add the one there, add background sprite. And obviously when we init, we first want to clear the sprites first, in case we init multiple times, which might happen on resize or something like that. So then all we have to do here is to call render on all of them. So basically we just go background sprite and background sprites. And all we're doing is we're going to bs.render, pass the canvas. Okay. And so in here, when we render, we just basically say, give our sprite and render it with the canvas at the rect. And we have to say render rect. Okay, fine. All right, and we don't have a render rect now as sprite. Interesting. So, so let's look at our render method. Let's see what we have to do different here. So we have the offset and we have the width. So basically all we have to actually do is rect dot. So we create an offset from the rect. No, hold on, we're not there yet. I want to just import this. So we say rect dot. I see that's what I. So the rect basically has everything in it, but I just want to basically have X and Y. So let's understand a little bit what each of these are. So let's see what bottom left is. So actually that's pretty much fine. I think we may just do rect.bottom left as the offset. So we can play around with this. Bottom left, since we are upside down with the canvas, right? But actually, no, we need bottom right. So sorry, top left actually. Doing top left, right? Because we want to render from here to here. It also will always do this, even though our canvas is upside down. If it's not, we're going to see that. Fortunately, we have a grid, so we're going to see immediately if something is wrong. And then we say width is rect.size.width, and then the height is rect.size.height. And that should work. So we don't have to have a render rect method, but we could introduce one. So all this, once we figure this out, we may most likely will do add to sprite proper. So because we might need it in other places. So once we figure out that this works. So now, for now, what we'll do, we'll just init the tiles here, and then we should be happy. And then we should be able to render. So now in our game, all we have to do is include this background. And you kind of see like how this starts working, right? Didn't even have to think much about it. We already have a sprite sheet now. We are able to pull out sprites of these images, and kind of things are starting to shape up to where we actually have a pretty good kind of an engine here that allows us to iterate quickly. So we need the background. Okay, and we will create that in the constructor. So background. So background. And what do we want in the background? Nothing. We need the time map. So that's interesting. We didn't need the time map before. Also, we don't have floor tiles yet. So there we are a little bit at a miss. So what are the floor tiles? Well, they're basically everywhere where in our time map when we create it in the level, right? We have the level here. Everywhere there is one of these or one of these or one of these. Well, we already are building a time map here, right? So we already built this. We already said where the walls are, right? So when we build the game model, we actually need to add here basically a list of tile position which has all the background tiles, right? Or we've called them floor tiles. Let's call them floor tiles, right? Okay. So, and then we need to obviously make this required. Like the player also needs to be required. Okay. So now we just need to make sure we give it to the game. We provide it when we build the game model. And so we can do that here, right? So when we build the game model, push it over here. Let's go to the game. Okay. So when we build this, we only consider player for now, right? We're iterating through our kind of prepared tile map, but we're only iterating through we only considering players. So now what we can do though, we can say if the tile dot background, or what do we have here? A wall, well, empty actually, right? If it's empty, it's not out of bounds, but it's empty. Then we basically should add this. But there's one problem. Yeah, so if it's empty, but there's another problem if we need to also add it if, for instance, where the player is, we need to also add it, right? So let me look, because the floor tile still needs to be rendered beneath the player. So let me see how we did this before. I think we just need to actually figure out like if it's not covering. So basically we need to figure out like is there a space that's empty and right. So basically we have something like this, which I will just copy over and we'll implement the method. So if, right? So we have floor tiles, we copy them from here. If the tile doesn't cover the background, right? Then we need to actually add a thing. So it's not only if it's empty, it's also if it's something like a player or like a pickup that doesn't cover the background. And so basically what we'll do is, and I'm actually just going to copy that one over because it's so trivial and it's such a mundane task to implement it. So basically we're saying if you're out of bounds and boundary wall, it's true, like it covers it. Out of bounds, we shouldn't render it a background, right? A boundary is a wall, basically. A wall covers it. But if it's empty, or if it's a player, or if it's any of these pickups, then we should add a floor tile, right? So then we say floor tiles to floor tiles. So now in our game we have the floor tiles. Now let's go back to our background and let's see why we actually would need the whole tile map. So let's see where we actually use it. We use it in one place, right? And we basically just need it for the calculation of what? Right here. We just need it in one place. So I will remove this. I don't like this too much because it could be anything. It doesn't matter. So for now, we just make it 20. It's fine. We don't really need, it can be the same for every level. Most likely we come up with a better way, with a better algorithm to render the background here. So we don't really need the time map here. So now we should be able to, what do we need now? We need the floor tiles, right? So, and these are part of the game. So it's game.floor tiles. Okay. All right, and background isn't used. Okay, that's fine. We don't need to update the background because it never changes. And then obviously we need to render the grid and then render the background on top of the grid. Okay. And now actually we should be happy. So let's see what happens now. It was called on null. We need to initialize the floor tiles. All right, and then we can basically make this a final. Okay, now let's see. Okay, good. See that? Now we actually are rendering the floor tiles. And as you can already see, like there are walls here. Right, you can see that that's the wall here, and this is out of bounds. So you can already see we're only rendering the floor tiles where they need to be, but there's a slight problem here, right? We are rendering them in a weird place. They should actually match up with the tiles. So let's fix that. So I think we did a mistake here. It should maybe still be, bottom left. So let's see about that. Okay. So maybe it needs to actually be the center. Okay, so now we are fine. Now we are rendering them correctly. So I don't know if this will apply everywhere with the center like this. But since we render everything centered, we should probably add this to the sprite now proper. So let's go ahead and open the sprite. And we include a void render rect. Right, and so basically what we'll do is pretty much exactly this. Copy that. That's it. And so now we can say render rect. Canvas rect. All right. And now nothing should have changed. Okay, cool. So the other thing is obviously like we can see that the floor tiles don't change, and they kind of look you know, the 20 was fine. We can always change. We may actually randomize the end rows, and then every time we get a slightly different floor tile on our levels. But that's fine. So like this is actually like it. Before I had it actually, according to the tile rows, but then it actually looked very repetitive. So this looks a little less repetitive than before. So at this point, we can check this in. And while we are checking this in and writing the commit message, we will actually start it also on, we'll stop this and we'll start it on Chrome to see if this still works. In the meantime, I will write the commit message. So actually what we also need to do, we need to create a tag, episode 09, start. Okay, and now we can add what we just did, and then game rendering floor tiles, and tiles, and push this up. All right, now let's look at the, Okay. Oh, okay, we don't render flow tiles here. Okay, now, ooh, that is very slow. I mean, the game works. It's just not very smooth at all. Oh my god, this is not smooth. So once we render floor tiles, there's much more rendering going on, right? Because like every time we basically, you have to imagine we paint the canvas from scratch. There are certain optimizations that we might do, like what's visible. Yeah, but this is not smooth at all. So we might actually say that on the web we don't render the floor tiles because that makes everything slow. I believe that if we were to implement it natively for the web, we'd probably not have the problem. That might be a thing where Flutter is just not performing very well yet with that regard. Okay, but we'll live with it. At least it still works. And again, we can turn that off if we wanted to. Okay, so we got that figured out. But we also want to render walls, right? So we want to render the walls. So that is also part of the game. And the walls also don't change. So this is going to be very, very similar to the background. So let's go ahead and say walls, right? So what do we? Why is this so similar? Because there's also going to be a list of tiles, right? So we're going to have this one, except that it's going to be called walls, right? Walls, and the only thing is that the wall is always the same sprite, so we will not have like a background sprite like this. We also don't need a sprite sheet. We will just have one sprite, and I'll show that sprite in a second. Okay, so let's worry about that in a second. So what we first need to do is we need to actually copy our asset over. So we have numerous folders here. I did it again, and okay, I learned how to get it back. This is going to be static. How we actually divide this up, we can change in the future, but basically here's a wall metal, and we might have different walls in the future, so that's called wall metal. Now obviously in our pub spec we need to include that now, right? Static stuff. And then in our game props we need to create another asset, new image asset. So basically we'll say final metal wall, let's call it wall metal, like the name of the file, equals image asset. And then we add assets, images, static wall metal. Okay, and now we go again. We open this up. We'll remember quickly the size. So this has 66 times 66, right? So 66 times 66, and it has one row and one column. Okay, row 1, calls 1. Okay, so now we got the wall metal image asset. So another thing is that what I would actually like to do is like I want to create a sprite really quickly from an image asset. So we have it from a sprite sheet, right? We say from image asset. But if I just want to create a sprite, and I'm assuming that I'm using the entire image asset, then that's also useful. And it's actually going to be much simpler than for the sprite sheet. So we're going to say sprite. So so we only have one column. So first of all, what we're going to do is we're going to assert that the asset dot rows 1, and then we can say can only needs to have 1 row exactly, and then we do the same for columns. Right, so then basically the sprite width is basically exactly the width of the asset, right? And so basically now we can create a sprite which has x 0 0 and then x y 0 0 and then the width and the height. Okay, so we say 0 0. Do we name these things? Yes, we are. So x is 0 and y equals 0, right? And then we have the width is, oh well, the width is basically the asset dot width, and the height is the asset dot height. Okay, so now it's not happy. It needs to be probably to double, maybe. Okay. All right. So now we got a quick way to create a sprite. So now let's go back to our walls. So we can basically say the sprite we create from the asset, and the walls we need to take in. So this one needs to actually come in, and the sprite we create, and then we say equals sprite dot from image asset, and then we just go to our game props, assets dot the wall metal. All right, so that's nice. So now we got that, and so there's not much to it. We know the positions, we know how to render it. So actually now all we have to do when we render it, right? The thing is, we have the tile positions. We actually we wanted to actually make into world positions. The question is when we do that, right? The question is when do we want to do that? If it's like such a huge overhead to do it on the fly, or yeah, probably like what we'll do is we'll also pre-calculate the rects. So let's here, right? So we're gonna call it init rects or something, and it's gonna do much less stuff, but a lot of less stuff, but and it's gonna just create world positions. And actually going to right. So actually, what this will do, it will actually really just create rects, because the thing is, we know what the sprite is. So in the other case of the background, in the case of the background, it wasn't enough to just have the rects. We needed to also know what sprite we wanted to render, because they were different. But here the sprite is always the same. So we can simplify this immensely. So we can actually also just iterate. So actually just remove all this. So what are we going to do? First of all, we clear the rects, right? Then we basically let's just assign the width is the game props tile size. I'm not a huge fan that we access this here. Actually, I want this to be a I want this to be a property. What's wrong here? Yes, it is. Oh. Okay, so I want to actually not way down in my game. I don't want to depend on game props. Where were they? Except here, right? When we just pull the okay. Except here, like this is very specific. This is fine, but we don't want to. We don't want to have the game props accessed everywhere with all kind of things. So we're doing the same thing. Here we're going to pull this in, and we need this now. All right. So it looks like we're not going to get to collision detection yet. We're running low on time, but I'm going to do my best to get through this. So basically what we're going to do, we're just going to go through each wall. Right? And then what we'll do is we'll calculate the world position. Wall dot to world position. So remember the wall is just a tile position, right? And then we calculate the rect, and that's the same way we did it before, right? So we get the world position x, and then we just move it to the we move it to the left bottom, right? And we could have probably maybe even avoided that and just rendered the sprite centered, but it's a rect, so it's really weird to have a rect and it's actually not really erect. It's actually like somehow in the center, and it just describes. So let's just I'm just gonna be like, so basically what I'm saying, I'm gonna launch the program in a second, and I'll explain this, what I was talking about. So basically we need to init the rects, and then here render, we just basically go through all the rects, and then we basically just say the sprite render rect, and now we can see, like, it's nice that we actually put that to the sprite, and so now we're actually done. And it doesn't have to have an update because it never changes. The walls never change. Even if the player will hit the walls, it will never actually change anything. So here it's complaining because it wants the tile size to be part of this, and so now we also need a walls. Okay. All right, so now all we need to do is initialize that, and it's very similar. Well, not exactly. So we need the walls, and what do we need? Oh, so it's confused now for some reason. Why are you confused? We need the walls and we need the tile size. So the tile size we have, but we need the walls. Well, how do we get the walls? Well, again, we need to go here. We need to create them. Final. We need to figure out the walls. Is another list of tile position, right? And so if the tile, right? If the tile dot wall, then we add to the walls dot add the tile. Let's see. Oh, actually not. We need to add the position. So the position is basically that. And you can see that we add everything centered, right? So that's why we have to move it over when we create the rects. It's not a big deal. And so now we have that, and basically now in the game model we need to add that as well. Walls. All this is required. It's kind of not cool that in Dart everything is optional once it becomes a name parameter. So what is complaining about now? Okay. Okay. All right, now it's happy. And now basically here we need to pass in the walls. Okay, so now we got that. Let's look at the bugs here, what we have. So yeah, obviously we need to now pass in the walls. So we have those now. game.walls, and then we need the title. And you can see like I'm trying to keep this whole pulling the game props. I'm trying to keep this kind of outside a little bit of these classes, except as I said, since like this is really tied to this particular, right? It's an asset. We need that asset, so it's nice to store it globally, but it's very tied to this, so it's fine that it can be exited there. Now the walls isn't used, and the tile size isn't used. So where's tile size isn't used? So the tile size here isn't used. Yes, because we want to actually use it here. All right, so now that's happy. And then walls isn't used. Well, that's because we need to render it still. And again, walls don't change. So we'll render the walls right after we render the background. It's on top of it, right? Okay, so now let's see if that works. And if that works, we'll probably call it a day. But we'll look first if actually we I want to see if I can improve the performance on Chrome if we remove the background. Oh, we actually are running on Chrome. Okay, we still have Chrome, so we can see the walls, and then we can see the tiles slowly being rendered. That is just, I think maybe somehow it's loading these images. Well, we already see one problem, like these walls are not rendered for some reason. So maybe we need to say also if it's bounds. Okay, so that's easily fixed. So let's close this, and we'll stop. Okay, and so we'll switch to macOS. And so what we'll actually have to do, I think, is when we are building the model, if the tile is a boundary as well, a boundary, then also we need to draw a wall, right? So now we can launch this on Mac. It is really horribly slow on Chrome. So let's just see how we can get. There was some way how you can get the executor, basically like where you're running in, right? I'm trying to see where you said before. Okay, but here now we have a complete map, right? And we can see we can fly around it, but we're flying through walls like crazy, right? So now it's starting to actually look like really similar to what we attempted to do. So we in this weekend we basically achieved almost that. So here's a problem though, right? So what's going on here? Why is there no wall here? So we'll figure that out. So let's go to our level and look at what we're doing there. So that's because we have nothing here, right? So we're missing that. So it wasn't a mistake in the program. Sorry, we just made a mistake when we created. So now if we refresh this whole thing, should be fine. Okay, cool. So now we're rendering the tile map perfectly with walls and everything. And we can control it. We cannot control it yet with in the phone. We only can control it with keyboard. Okay, so that's fine. So what I want to do is I want to make a commit with this because this is working great. But then I want to look for a second just into how we can improve rendering on Chrome by maybe not rendering the background here. It kind of sucks. So the wall here is just that the background, right, is big. Maybe what we could do is we could decrease the resolution a little bit. Maybe that would work. So we'll experiment with that. But first of all, we check this in. Game rendering background. Well, actually, let's see. What did we already check in the background? Oh yeah. So what we actually need to do is game rendering walls, right? And so now what I'll do is I'll open this in a preview, hopefully. How can I open this? Please let me know how I can open this. Oh, it was just revealed in the Finder and open there. Okay, so what I want to see is if I make this smaller, just size, right? I want to actually, I want to do percent. Here we go. So if I make this like 50-50, right? And then save it, right? Let's see now. So now we got 512, 512. We need to obviously go to our game props and change that. Okay, and then we need to obviously restart. First of all, I want to see if it still looks good on Mac. And you might be thinking I'm crazy to just like change this, but we still have the change in here, right? So we can always just check out Git again, and we'll be back to normal. But I have some inkling that maybe this is like the issue, and like see if this. So actually now this is rendered. This rendered on the browser. We no. Okay. This isn't Mac. Okay. It looked kind of weird, right? Maybe it's because the first time it loaded this ever. But it renders fine here. And now let's see if we have any improvement on Chrome with that. I mean, it's starting to get really small, right? So basically the tile size here. So if you have 512 divided by 8. So that's 64, right? So, but we on our tile size is 40. So we're actually rendering it small already. So if we actually want to render it we just want to size it to 4040, then it could actually be 320. So that's something that we could consider. Okay, let's see if that improved anything. Oh, it's still horrible. Actually, I think it got worse. Yeah, I'm not sure. I think it actually got worse almost. So let's just like shelve that idea. Yeah, so we have a horrible frame rate here. It looks really junky. So it might be that, right, you know, it's playable on Chrome, but so what we'll do instead is we're going to check this out again. This is not a remote solution. And what we'll do instead is we're going to look at like Flutter detect platform. So I think there's something platform. Okay, so in the game props, right, we say we'll put the here static. It's not going to be const because we can't detect this until later. Under background. So we have to import something, I guess. Dot is. Oh, that's interesting. Interesting. So what's the platform actually? Interesting. So that's not really what, maybe this is what we want. So So basically, okay. So we want not case web. So we want to run in the background only if it's not running in the web. So, and then we'll basically encode this all here. Maybe we'll just what we'll do is we create a no-op. Well, I can't really do it because you have to assign it to a background. So basically, okay. So what we're going to do, we're going to have final bool active, right? And then we're going to do this to active. We're going to rename to isActive. Is active, right? And so now basically, if not is active, if not is active, return, right? And the same here, we don't have to prepare anything. Wait, that's a task. Okay, so now we need to obviously pass it in. So here we're still in the game, so we can easily say, come on, game dot render background. Okay, so now when we refresh, and see, this is what happens if you're trying to rebuild when it's already rebuilt. So now you can see like this is a better performance. So on the web we just can't really render this beautiful background, unfortunately, because otherwise our performance just goes to hell. Let's just see that it still renders on Mac though. Let me call it a day. Not running floor tiles. Okay, so this is on Mac. It's still beautiful rendering this, and it's much more performant. I know that the walls don't look the prettiest, but we'll live with it. Okay, so now we're gonna tag this. We have tag. Okay, and now push. And then we'll build in a second. We'll build the web version and we'll push it up. And then we're pretty much done. And then tomorrow we'll continue with tomorrow we'll do collision detection first. So obviously we don't want to fly through walls. We have to kind of look at if we are hitting walls or not, right? So what I'll do now is I'll build it, and most likely we'll make this a script later on, right? It's working quite nicely. I wonder why it's such a big deal to render these images. On the browser. But I mean, this is all like on the master channel, right? Or on the dev channel at least. So it's not all ready yet for prime time. So that's why we'll just find a workaround. And now I'm just going to copy the build web start to our little GitHub pages thing. Go there. Game. Basically, for this is just basically walls, right? Because we removed the. Have you tried a different browser? That's a good point. Let me actually do that. So this one gives us a route here. So let's just try Safari. See how that looks there. It might just not work at all. Okay, so it works in here. Oh, okay. So it works. It seems a little janky in here. I don't know if I have Firefox installed. No, I don't. Might be a good idea to install it, but I doubt that it has to do much with it. I think it's just the code that gets generated from this is probably not the best at this point. Like, so what we'll do is we just go to the game props and we can say we just return true here for now, right? So it's always running in the background. Now if I restart it, but actually I need to. So let's stop everything, and then we'll launch it again in Chrome, and we'll load it into Safari. So this will close. But that's a really good idea. That's a really good point. Maybe it renders better in there, but I kind of doubt it because I think it has to do with, I don't know what it's doing wrong. It might be just, instead of caching the images right, it might just be reloading them every time. I mean, so we're creating a sprite, right? So the sprite is here. And so we draw image rect, right? And so we give it the image. And the image, if you think about it, is just this thing. And so, oh, that's weird. It didn't, okay, now it's, okay, so see, oh wow, that's just horrible. So let's just do Safari and see if that is a little better. It's also, we have a really big open, so, oh wow, so it's, oh, yeah. So I think like, it's almost like as if it's loading. Actually, we could verify that, right? We can look at the network traffic here. And I have an idea that maybe it's loading the image every time when we draw it. So let's just look at images here and let's just refresh. Okay, so here we go. What is all this? So that's a problem. So somehow blobbing, creating a blob for each of these images and serving them. Yeah, that's just horrible. So basically we're creating a sprite sheet. And for each sprite, it's just weird. Hold on, I'm very confused. So we're creating an image, right? And so it seems like, so we're creating an image and all that image at this point is data, right? Because we actually already did a sub image, right? Because we already pulled out the tile of it. But then basically here we can see that it is loading the image every time. So that's the problem right there. And it doesn't seem to be caching it. There seems to be no, yeah, I don't know these IDs, but yeah, so that's horrible. So that's a bad solution. Well, it might actually be better maybe once we build it. So that's something I didn't consider yet. So let's look at that actually. Which means I have to build it again, which is fine. We're gonna build release and we're gonna build web. So there is no such thing as release. Maybe like that. Okay. So now it's building this for the web. So what could have happened is that maybe only in development it's doing this in this weird way. Maybe when it's building, it's actually baking in the images correctly, like it should. I mean, it could probably just create data blobs. That's fine. The only thing it shouldn't reload every time those images. So what we're going to do is serve this folder, and then we go to localhost. So we're going here. We're going to localhost 3000. Okay, so let's see if that's. Oh, what the hell? That's not much better, is it? It's still really janky. And I guess you can also verify that it did things in a stupid way. So first of all, did you see that you download floor tiles like a lot of times. It's almost each time we created a sprite from it, and then it keeps loading the image. So that's just horrible. Again, I mean, we can't complain too much. It's just basically in the infancy, right? Basically, like the whole. So we don't want that change. So the whole thing about Flutter on the web, right? Even like Mac on Mac desktop is still like in its infancy. So we can't really complain too much that there are performance issues. For now, it's basically make it work, right? And then you can make it fast. So I'm not going to complain too much about it. And I'm going to end the stream here. Join me tomorrow again at the same time. Like right now, we started at 9 p.m. Central Time. Sorry, Eastern Time. And we'll just do the same thing. It's actually in the schedule in my Twitch. So thanks for joining me. And yeah, thanks for that suggestion. Always good to try this. I didn't think of that myself. So thank you very much, and hopefully join me tomorrow. And I didn't mention this yet, but all these videos I'm basically copying them onto YouTube with links to. I'm going to put the links to the tag where we were at the moment for each episode, so people in the future can watch them if they missed the stream. Okay, thank you very much, and I hope you can join me tomorrow. I'm ending the stream now. Thank you. Bye bye.